of y is equal to tan inverse of 1 minus x over 1 plus x. So what this means is tan y is equal to 1 minus x all over 1 plus x. So since we are continuing with differentiating implicitly, it means that dy over dx of tan is equal to sec squared y. This can actually be done when you, at the beginning, when you are doing the derivatives of trig functions. So the derivative of tan is sec squared y. This is also determined using what we call the quotient rule. Maybe I can just show it real quick here. The quotient rule says dy over dx. If we have got a quotient, two functions that are in terms of x, and y is the subject formula, if we can write them like this, not really. If f of x is equal to u over v, therefore dy over dx, the proof can be done at a later stage, is v u prime minus u v prime over v squared prime. So we are going to use that because we know that tan y is equal to sine y over cos x. So the derivative of tan y with respect, in fact, the derivative of tan y with respect to y, in this case, is going to be equal to v, which is our cos y, u prime, which is the inverse of sine, which is cos y again, minus u, which is sine y, and this is also minus sine y, all over cos squared y. So the denominator becomes cos squared y plus sine squared y, the numerator rather, over cos squared y, which is just 1 over cos squared y, which can be translated as sec squared y. So that's basically where this is coming from, the quotient rule. And again, if we had to do the quotient rule of the right-hand side, which is 1 over u, so you are taking 1 minus x over 1 plus x, and you call this your u over v. What it means is the derivative of 1 minus x over 1 plus x over dx is v, which is 1 plus x, times the derivative of u, which is just minus 1, minus 1 minus x times the derivative of v, which is just 1, divided by 1 plus x squared. This simplifies to minus 1 minus x minus 1 plus x all over 1 plus x squared, which is just going to be equal to minus 2 over 1 plus x squared. So we're actually going to have the right-hand side is minus 2 over 1 plus x squared. All right, so simplifying that gives us dy over dx equal to minus 2 over 1 plus x squared times 1 over sec squared y, like this. However, we need to replace the sec squared y with the x's. So it starts from here, again, appreciating that cos squared y plus sine, let me write it here, cos squared y plus sine squared y is equal to 1. If I divide this function with cos y squared, I'm going to get 1 plus tan squared y is equal to sec squared y. So in terms of tan sec squared y, which is this one, is this. So it's going to be 1 plus tan, of which our tan is this one, which is 1 minus x squared over 1 plus x squared. That's our sec squared y. We can further simplify it to become 1 plus x squared plus 1 minus x squared all over 1 plus x squared as your sec squared y. Simplifying it again further gives us, do we actually need to simplify it further? Not at the moment, but let's just do it. We're going to have 1 plus 2x plus x squared plus 1 minus 2x plus x squared all over 1 plus x. I am not going to simplify this because I see that it's going to cancel there. So eventually, this will translate to, as you can see, this and this are cancelling. This will translate to 2 in bracket 1 plus x squared all over 1 plus x squared. So coming down here and make the substitution properly, it's going to be 1 times 2, 1 plus x squared all over 1 plus x squared. So our answer is what it is right now. So we are going to, let me create space here. So what does this mean? This means dy over dx is equal to minus 2 over 1 plus x squared. Then we are going to invent this. Since we are multiplying, it's just going to become 1 plus x squared over 2, 1 plus x squared, like this, of which these two cancel and these two cancel. Our answer is going to become minus 1 over 1 plus x squared. That's as required. So the route to getting to the answer is to master implicit differentiation. That's the easiest way to do it, rather than to try to find 1 over dx over dy, then try to convert back.